And we're live. So, okay, go ahead. Shoot, what's the question? How can I help?
Is there anything like any specific topics or anything you want us to elaborate on in it? Like I know we're supposed to find them ourselves, but is there any like very specific ones that you want in there for sure?
Well, let's just talk our way through it, and you'll probably kind of read between the lines as we go. So, what's the basic limits that you're trying to break down?
Would it be like the size of the muscle?
That's one potential thing. Because
How
what
much
are we trying to get?
increased muscle size?
Potentially. Now, let's just go, and we're going to talk about a bunch of different ideas, then we'll go into those a little bit more in depth. So you're once again to contextualize it, because not everybody hit record before you started talking. We're talking about limits to speed, right?
I think it's limits to strength, isn't it?
Oh, you want to do limits to strength?
I
Okay,
think that's the
sounds good.
next one.
All right, well, they're all going to come up anyways. Okay, so limits of strength. Absolutely. Turns out a bigger muscle is a stronger muscle. Now, does the fiber type really matter when it comes to maximal strength, not power?
No.
Exactly. Now, why can't our muscles just keep getting cartoonishly oversized and we're just going to keep getting stronger? Why are we eventually going to hit a peak for any human being, irregardless how much drugs or cocaine they do pre-lift?
Does it have to do with like how we talked about once you get to a certain point, you're so heavy that you're burning more than you can take in? Like you're burning more calories and stuff that you would use to build muscle than you can take in?
Yeah, that's pretty rare for a human to get to the point where they literally can't eat anymore to gain weight. But that is a potential limitation, is caloric intake to keep up that amount of muscle mass. But there's going to be a couple things that happen before then. One of which is, okay, so we're making these muscles bigger so that they can pick up a heavier weight, right?
Yeah.
Okay. Now, as you can keep yourself unmuted, it's no worries, unless you got dogs barking in the background. If your muscles keep getting bigger and bigger, okay, what's going on with your body weight?
It's increasing.
Okay. So now, can you see what there might be a drawback or something that's kind of going to keep adding more limits to your maximal strength as you get bigger? It's okay. Take a shot, Haley. If you're wrong, you're wrong, but we're just talking through it. And Sarah, we're talking about limits to strength. So that's kind of getting into the nuance, and you're obviously more than welcome to join our conversation, plus any questions you have over chapter 6, chapter 5, or anything else in general. But go for it, Haley.
What was it again? Can you re-say it? Sorry.
Yeah, no worries. What's the problem? What's kind of the factor that's essentially kind of working against you a little bit, but it's going to eventually be a limit to how big, or it's limiting your strength as you get bigger and bigger?
Is it like your actual range of motion?
That's a potential. Very rare that anyone's going to get to be so big muscular wise that they're not going to be able to move that well anymore. Potentially, but that's probably not a real limit to your strength.
Do some of these reasons overlap with the limits to muscle size one?
Kind of, but not really. Instead, Haley, think of it like this, okay? Obviously, you and I are two very different sizes, and I am markedly larger than you are, more horizontally than vertically, if you catch my drift. Now, if we were to give you the same muscle mass that I have, but somehow could do some type of black magic where you wouldn't actually be any heavier, so you have the same amount of muscle mass that I do, but once again, our body weights are very different. Who is going to be stronger relative to their body size between the two of us?
Me, because I'm not as big.
Bingo, bingo. So if you gained weight to get to my size, your true maximal force is going to go up. However, your strength relative to what is probably going to go down a little bit.
Body size.
Bingo. And so now we're talking limits. So now you think about the difference between me to you is nowhere near the same as the difference between me and like Brian Shaw or Halfbore Thorson when he was at the peak of his strongman career. Both those guys weigh about 450, literally twice my current body weight.
So one of the limits is your actual body size.
Bingo. Does that make sense? It's called what's known as allometric scaling. As we get to be bigger and bigger, more of our tissue is literally just devoted to carrying that body mass around.
Okay, yeah, that makes sense.
Yeah, it's pretty damn rare. You're going to get a human being that's so big, muscular wise, that it becomes really inefficient. But to give you an idea, the best deadlift really is Halfbore Thorson, to my knowledge, and that wasn't in a true powerlifting competition. And that was 1,100 pounds or a little bit over 1,100 pounds, while he literally weighed about 450 pounds, which means it was about, around 2.5 times body weight. Okay. The best deadlift body weight relative was, there's probably been ones that are better, but one of my favorite deadlifters is Lamar Gant. Lamar Gant pulled over 700 pounds at a body weight of 142.
Wow.
Yeah, literally deadlifted over 4 times his body weight. So if we just look at the deadlift strength in relative terms, Halfbore Thorson is kind of clown shoes. Like the guy's not even pulling 3 times body weight.
Yeah.
However, as you get to being bigger and bigger, you need more and more literal muscle mass to actually carry, the rest of that body around. So that's a potential limit for strength. Okay. Now let's go back to your muscle size, because there is limits to how big a muscle can get, but now we got to think about muscle architecture. Okay. So now we're actually incorporating a little bit of biomechanics. What do you think might be a limit there as your muscle gets to be bigger and bigger?
You said it wasn't the range of motion thing, right? Because that's really rare.
Yeah, it's a range of motion probably won't be a real issue for anyone that's programming relatively well. I think you run into the issues with, do you remember when we talked about angles of pronation, when we talked about muscle?
Is it like the angle that you can pull the most force or create the most force at?
Okay, now we're thinking about optimal leverages, which we're going to get to in a few. Okay, but that's definitely another thing we're going to get into. Okay, so as your muscle gets to be bigger and bigger, okay, so like look at your bicep, okay, of however much or little tissue you have, okay, and you see how your bicep for the most part. So if we see mine, there's a certain part that reaches up. Deepest fibers are pulling in that straight line, which is going to give me it gives you 100% force transfer. Make sense? Now, these fibers that are a little bit angled up, they're actually not as efficient. Most of the force is coming this way, but I'm obviously losing some of it this way. So when people get to be just absolutely like monstrous muscles, a solid amount of those muscle fibers are barely giving them any extra force production because their angle is so poor. Okay.
That makes sense.
Pretty damn rare. Okay. That is potentially something can happen, that your muscles can be so big that they literally, as your muscles get to be bigger and bigger, they lose a little bit of efficiency. And at a certain point, they're going to lose so much efficiency that the extra weight from them actually isn't really making you much stronger anymore. Is that going to happen to you or I? No. And Lord knows I've been trying to do that, and I have failed well over a decade of training. So, I mean, if you can pull that off, that's awesome. Props. Okay. But let's go back to your angle of pull. Okay. So what could we do? And this would be surgical intervention to make you stronger, like once you recovered from that surgery, without actually increasing the size of your muscles. What can we do when we think about biomechanics to increase your strength?
Would it be taking those fibers, like you said, that are at that angle and like reattaching them to where they're flatter?
Okay, now that's slicing the muscle in pieces. So that's going to be a limitation that we can't get around. But think about leverage.
Oh, would it be decreasing the lever arm length?
Yeah, so we could somehow break your arms and your legs and make them really short. So you wouldn't have as long of a lever that you have to lift against. And what's the other thing we could do? Think about the force producing side, the force we produce.
I don't know.
It's okay. So what anchors the muscle to the bone?
Tendons.
Okay. So think about your good old leverage equation. What's the basic leverage equation?
I don't remember.
Force times something equals the resistance itself multiplied by something again.
Is it the length?
Force times force arm equals the resistance times resistance arm if we're in a balanced equation.
Okay.
Okay. So we could somehow like literally lop off some ulnar and ulna and radius, and my forearms would be shorter, then my upper arm would naturally be stronger. But what's the other thing I could do on the force side to increase my strength?
It has to do with the other variable, doesn't it? Of the
Yep.
equation. Yeah, I've already forgot what it was. But I
Force
know.
arm. What can we do with a force arm? It's okay. Take a shot. Sarah, you're being so quiet. Go and give us a comment.
Oh, I wanted to ask about biomechanics. That's why I was like, just gonna wait. It's just a simple question.
No, it's okay. It's okay. So actually, this is actually playing into biomechanics. But I'll let Haley keep stewing on it for a moment. Sarah, what's your question on for biomechanics?
So tomorrow it says that we have lab 2 due when class starts, and there's nothing posted for lab 2. Like,
Well,
there's
that's
no
in all of the labs you're doing for the spring. So if you go to that document, you can scroll down, you will literally see lab 2 listed directly after lab 1, and then lab 3 is after lab 2.
Okay, awesome. And then for the homework, I had like a question for 2 of them. I don't know what the answer would be on the
Okay.
homeworks.
Okay.
Do you want to wait or?
I mean, Haley, do you got a guess yet, or?
No, I'm kind of lost.
It's okay. It's okay. So think of it. Sarah will come to your questions in a few moments.
Okay.
Bicep attaches here. Okay, right? So that is my freaking force arm. It's really short. What could I do to give myself a better leverage?
Would it be increase the length?
Yeah. So we'd slice off my bicep tendon and insert it like here. And then I have this massive leverage, which I wouldn't have to be any more. There would not need to be any more muscle mass. But now I've got such better leverage, it's naturally going to make me stronger.
Okay, gotcha.
Yeah. Not a smart decision. I would thoroughly suggest not cutting a tendon off to reattach it. That's no, your risk reward ratio is really inverted. But like anything else, that is a potential situation where you might see obviously some enhances in performance. So those are kind of the biggest linchpins of kind of limits to how strong we can be.
Okay.
You know, as far as, you know, you've got your anthropometrics, you've got your biomechanics that are naturally going to be limiting you. You've got obviously how big your muscles are, which, you know, that can be something that, as like I said, we get to be bigger, we have got kind of less efficiency. It's still going to be useful to be bigger. It's just not going to be as useful as those initial gains were. And of course, you know, we've got the wonderful components of, yeah, that wonderful angle of pronation and how that's going to change.
Okay, that helps a lot. Thank you.
Hey, no worries. All right, Sarah. So what can I help you with on the biomechanics questions? And then I guess you guys don't really have any questions. I guess it's going to be a real quick and easy review.
So it says the linear motion of a projectile is influenced by 3 key factors: the angle of release, the height of release, and I thought it was the velocity or like the direction, but that's not the right answer.
You didn't count the velocity as the right answer in that condition?
No, I wrote velocity of release and direction, and none of those were right.
And they may be looking for initial velocity, but
I think I tried that too.
either way,
I know
you're
one of them I
correct. It's
did.
just, no, it's okay. I'll take a look under the hood and see what's going on there. But you're, yeah. The height
Okay, and then
the angle and the speed. Like if you got those.
the 2 athletes, I didn't try speed. But are those interchangeable? Because like in physics they aren't, but like in here we've used them kind of interchangeably.
I like to use the term velocity, but I will on occasion speed comes up just because, as bad as it sounds, a lot of your other classmates, that's really how they're used to seeing things. And velocity can be a little bit daunting, but you're right.
Yeah,
velocity is
because
the real truth we're talking.
the scalar and measure one, where it's like how fast an object is traveling, I wrote velocity, but it was actually speed. So that's why I was like a little confused. So it might be speed for I didn't try that on the linear motion one.
Yeah.
2 athletes throw a javelin for a maximum distance. They release the javelin at the same height and with the same angle of release, but one throws it further. And it's like, what's the key variable difference? I also put velocity for that, or force, and those weren't the right answers. And I also did initial.
You are correct. It would not
Okay.
the right answer would be maybe it was initial velocity that
I wrote initial velocity for that one too. And yeah, because okay, so I have like oh, you can't see it. I have a doc of like all the answers, and I write down the right answer so I can like look back and like do all that, so I don't have to just keep retaking it. Because then I get confused with like the stuff that we have. So I wrote like anytime I got something wrong, I wrote what it's not, and so that's how I know I did that.
Okay, no worries. That's okay.
And
you're correct.
Okay, and then what was it? A basketball player makes a free throw and falls short of the hoop despite having enough height. The basketball player needs to apply a greater blank force to make his free throw. I wrote horizontal force, and it's also not vertical. And those were both wrong. And I'm kind of confused on that one.
Could have just been more force in general, but once again, you're correct.
Okay. Okay, that makes me feel better. I was like, am I like completely lost?
No, it gets persnickety, and it's like anything else. I think I write in the right answers that everybody would eventually get to, but obviously I don't. So
You're good. No, I was just a little confused about that. And then for lab 6 this Friday,
Yep.
it was just since no one's here, are we using the body pod, or are we just using that one? Or yeah, the bod pod.
Yes, we are aiming to use the bod pod for the lab. And then obviously, aside from doing the skin fold calipers, we'll use the Tanita, and hopefully we'll be able to get the Sozo to go running. And then for some of you guys, depending on everything, we'll get you guys on the DEXA as well. That does require you guys removing all of the metal you might be wearing on your body. So obviously we're typically talking jewelry, piercings, etc. before you get on. But we just have a little waiver if you're female that you have to fill out that effectively says I'm not pregnant. And the reasoning for that is because you don't irradiate pregnant women. It's kind of a good old kind of blanket statement there. So that unfortunately is why you ladies have to fill that out, but the guys don't. Because it turns out we're not really too, well, I mean, we live in a strange world, so who knows, maybe that might be more of a factor I should consider than I am.
Yeah, I was just wondering because I've had to use the body pod before and it went really bad. So
no worries.
I was a little nervous.
That's okay. 1 second, Haley, that's okay. Drop on out whenever you're ready. Thanks for hopping in, and stay safe. I'll see you guys obviously hopefully on Friday. And then yes, if Sarah, let's face it, the bod pod is a small container. It can be easy as folks have got claustrophobia for them to have, a bad time. And that's not obviously our goal. Instead, what we're trying to use is kind of triangulate where we think your body comp really is by utilizing more than one method. So we will go ahead and obviously not bod pod you if that's going to be an issue.
Oh, no, it's not claustrophobia. I get like, I fidget a lot and you're not supposed to move in it. And I like volunteered to do it at, I did 4-H for a long time, and we did like a nutrition class, and I just sit there and I was like fidgeting too much, and they were like, you need to stop fidgeting. And I was like, I literally can't. I don't know how to. I thought I was. So yeah, that's why I was like, I don't know if I can. I don't know if it'll come up with a good score, because they tried it on me for literally 2 hours and they couldn't get a score for me.
It's okay. We'll do our best, and that's okay.
Okay, awesome. Thank you so much.
2 hours though, no worries.
Tomorrow we do have class, right, for biomechanics? Okay.
Yep, I have every intention of being there, and we're also going to try to go through lab 2 in class as well, and kind of show you guys how to break all that down.
For lab 1, or for lab 2, we're still doing our own personal, like if we group for like the information we write down, right? Yeah.
So you're going to obviously do the limb breakdown for your you're going to do all those lengths and measurements, but at the same time, yeah, we'll go ahead and figure out what are going to be the weight of those areas. And that's what's going to be useful for you guys for your projects.
Awesome. Thank you so much.
No
Hope your
worries.
wife's doing good and have a good day.
No, you too. Have a great one. Madeline, what questions can I answer for you?
Okay, so this might be like a silly question, but I like do obviously all like the homework quizzes. But when it comes to the chapter quizzes, I never do too well on them. And like I'll review before I take them. And like I just want to know like a better way to like study and prepare myself for them because I find myself second guessing my answers.
Well, first and foremost, remember you can take it as many times as you want. So it's fine to second guess yourself, go through and then figure out which ones you got correct and got wrong in the first place. Because then obviously you can always just take it again and just kind of brute force your way through it. And so my thought is, look at the slides, for lack of a better term, skim the chapter, so to speak, because certain parts of this class should be reviewed from taking physiology. And then it's got a couple little modifications to what you had to learn there. And then after you get through, take the quiz the first time. And the ones that you're like, I have no freaking clue whatsoever where I'm at. That's what you got to sit down with the material and really go through. And the ones you're like, okay, that was just a slight little mistake I had in my reasoning or something else, or I just got tricked up. Obviously write it down, figure out what the right answer is, and then kind of go back to it again. But the basic idea with that is trying to make it as low stakes as possible for you guys. So you should never be afraid to just brute force a number of attempts. And then, if you're taking it 20 times and you're still not getting everything right, okay, we got some questions there. Like I'm kind of impressed, yet obviously I've got my concerns too. And it's the same thing. If you figure out you get the same question wrong twice, you look at the book, you don't figure it out, you look at the notes or you look at the lectures before we meet and it doesn't make sense, then that's a like immediate question as soon as we come into class to talk over it, like what the heck is going on here?
Yeah, because I'll sit there and I take like the homework quiz until I get the 10 out of 10. That's just how I feel like, and I usually like the ones that like I struggle and I'll write them down. I don't know why I do so bad on the chapter quizzes. I don't know what I'm doing.
No, it's like the homework quizzes are meant to be kind of the more like, straight up, do you know the facts type deal? And then obviously the actual like weekly quizzes, I try to make it application knowledge. So can you apply it? And that's what trips up a lot of people, is they're really good at memorizing the facts, but they're not quite good at understanding why we memorize them in the first place and like what use do they really have?
I gotcha.
So yeah, it's a different way of thinking, but it's the type of thinking that's going to serve you better in your life, because that's, turns out how life really works as far as, having the straight up facts on your top of your head is good, but being able to apply it. It's like, I wouldn't trust a broke financial advisor. Like if you can't apply the knowledge you have, like, why am I going to you?
Yeah, that makes sense. I gotcha.
Mm-hmm.
Yeah, because I've been putting off the biomechanics chapter quiz just because we do have class tomorrow. So I can like hear the lecture before I take it. I do better in person.
Well, no, we actually already went through those quizzes last week. That was chapter 7 and 8.
Okay, is that what it is? Because whenever you like are looking at the chapter quizzes on the outside, it says chapters 11 and 12. And then when you click on it, it says chapters 7 and 8.
Yeah, the book.
Okay.
So whenever I everything, they were chapter 7 and 8 in the book, and then they changed it. So now it's 11 and 12 because they had to put a new coat of paint on it so they could charge you guys more for it. That's the reason why I refused to update any of my books for years. So I was like, you know what? They haven't changed anything in these classes. And the things they have changed, I'm going to put in the slides anyway, so they don't need it to,
makes sense.
books on books. But now that EKU is paying for your books, whatever.
I'm glad they are. I will not lie.
Exactly. I don't blame you whatsoever. Any questions? Going through, I was looking at your quiz, the question about hypertrophy and resistance training.
Yeah.
What can I help you with there?
I just want to hear it like re-elaborate it, like, because like I understand like the atrophy portion of it, but I just like want it to be like reiterated, if that makes sense.
Yeah, it's okay. There's always a lot of different ways we can go about it, but the long and short of it is start off with the model of your body is constantly adapting to the demands placed on it. And specifically, it's adapting to be as good as it can at what you seem to encounter with enough frequency. Now, when we encounter it, we're naturally going to have primary signals, and these signals are going to be caused by a variety of different initial mechanisms. So when it comes to muscle size, muscle hypertrophy, we've got literal muscular tension. So how much force is this muscle having to produce? And it has ways of detecting the forces had to produce. Number two, how much damage has occurred to this muscle, which tends to be related obviously to number one. And so that's why we're typically doing more than just one rep of any exercise. You're doing multiple reps, multiple sets. Number three is metabolic byproducts. So this is that wonderful, not lactate the problem, but the proton that comes with it, high CO2 levels and otherwise, where it's like, we are really having to use this muscle a lot. We're having to use it and we're getting a lot of damage, and it's having to produce a lot of force. And then the fourth major causative factor of telling your muscles to get bigger is just straight up hormones. That's why guys went through puberty and all of a sudden their muscle mass started to show up overnight. Obviously, you ladies, not so much. Obviously, other parts of secondary sex characteristics started to show up. And so with those four signals, there's only really three that we've got direct control over. Obviously, fourth, if you're willing to play around with compounds that you probably shouldn't be. So your body is, once again, adapting these demands. Every muscle in your body, unless it's having those four signals acting upon it, and obviously the signals can vary in intensity, are going to either get smaller, stay the same, or get bigger. And so yesterday, because obviously I did not work out on Monday, I got to spend that obviously supporting someone I generally obviously deeply care about. And so
Yes.
what happened is, I went and squatted in my garage. And as I stand here and talk to you, pretty much everything on the posterior chain of my body is giving me the middle finger, because I lifted heavy loads for moderate to high reps, along with enough metabolic byproduct, the burn, so to speak, in the muscle, that I did damage to my tissues. So now I've given the signal to my body like, hey, we need to at least keep this muscle mass he has, maybe even increase it some more, because it turns out he's going through some stuff physically. And so if we were to, put me in a, like the movie WALL-E, put me in one of those chairs where just wheels me everywhere, feed me, whatever the heck I want, and then I never move, I'm not having those signals anymore to tell me to maintain that muscle mass. So slowly over time, the body's going to atrophy those muscles because the body's not getting a signal to keep it. And muscle is energetically expensive. Fat takes about 1 to 2 calories per day to maintain about a pound of it. Muscle takes somewhere in the neck of typically like 10, maybe 15 to maintain a pound of muscle. And so if your body, if you're going to be in a caloric surplus, your body's like, you know what, let's just gain fat. It's cheap. We can keep it around and we've got extra energy we need. Yeah, it sucks, but that's the truth. Whereas I was like, wait, why do we have this extra muscle? This shit's expensive. Like, if we don't need it, let's not have it. And so, there has to be those signals. And then obviously the calories and micronutrients, protein, et cetera, to support that muscle mass, both maintaining it and building it. But at the same time, it comes down to signaling, and then the nutrition supports that signaling. So I could, once again, go eat as much Haagen-Dazs as I want. And if I'm not exercising, my body's like, sweet, we need to save up for a famine that may or may never come. Whereas if you're giving yourself those signals like, we're working out hard, there is, I don't know what's going on, but there is something incredibly heavy and oppressive on this guy's shoulders multiple times per week. And if we don't do something about it, it's going to crack us in half. Then the body's going to go ahead and react accordingly. So, and when it comes to, you have to think about peak forces relative to that individual's ability to produce force. And muscular damage is also relative to that muscle's ability to tolerate damage. So for example, myself, we did that 9/11 stair climb with myself, Professor Perry, and then 2 of my friends. The next day, I'll let you guess, what muscle do you think in my lower body was sore from climbing up and down all the stairs? There was only one, well, technically one group, and they were very upset with me.
Was it your quads?
Nope.
Or no? Or is
Nope.
it like more of like lower, like in your calf region?
Yeah, it turns out for decades, I've done a lot of heavy squatting and deadlifting. So the muscles of my thighs and hips are pretty well
We're
conditioned.
good.
Yeah, definitely neglected doing calf raises for at least a solid decade or two in there. So
Oof.
no, it's just the truth of the matter. It's, calf size doesn't make a difference in powerlifting and Olympic lifting or strongman really that much. So I straight up neglected it. Compared to the primary movers when it comes to squatting and deadlifting, being things like quads, glutes, and hamstrings. So yeah, they were fine. Low back, fine. Calves, annihilated. You would have thought I was wearing, like, when I was barefoot, you would think I was wearing like hardcore, like downhill ski boots, because my ankles could not move to save my life. Like I was pretty wrecked. So,
I believe it.
yeah, but so that's getting back to, once again, the individual level of fitness. So hence, when we're trying to design a program to build hypertrophy in someone, all those mechanisms we're trying to get to activate, we also want to think about relative to that person. So
Okay.
yeah, like if I'm going to write a program for anybody, I'm not going to tell them like they need to go do what I do, because I'm adapted to it. Instead, the first week for them might only be just, let's just work up to one heavy set of squats and just see how it looks, and we're going to cut it. And that'd be enough for them to be absolutely just destroyed. For me, and this is the amount of volume that makes me sore, as I've obviously told you already, and there's accessories in there, but it was really only after real warm-ups, only 7 total real work sets of squats between a safety squat bar and when someone's front squatting. And that's enough that I very much so perturbed my body's equilibrium. There's other folks that are so well-trained and well-conditioned that they might have to do something more like over 10 work sets in a given session in order to elicit the same type of damage and soreness. And then, yeah, there's other folks that might only need 1 or 2. So hence, when we're talking about hypertrophy, we have to keep sending the signal to the muscle at a rate at which the muscle has time to recover and then send it again. Like, I'm not going to be doing lower body again today, because it turns out I'm already relatively wrecked, and that's not going to help. But I am going to do a more hamstring dominant workout tomorrow, and then I'll be doing another lower body workout. Likely, yeah, it'll be on Saturday, just because of the way the schedule's worked out. And then not have to squat again until Monday. So you have to divide up those stressors based on how well people recover. Some folks, they're ready to train the next day, which that's awesome. Some folks it takes, and it's also by muscle group as well, which is kind of tricky, where things like calves, biceps, rear delts, kind of upper back, that tends to recover pretty quick. Abs, you can train those multiple times per week. Whereas if you really, to the point at which you're going to be sore that day and maybe be ready to go in 24 hours with a real, session that has caused some, well, a good way to know if your training session was effective for the muscle group you wanted to is kind of not so much local fatigue, but a little bit of dysregulation. So you're not exactly just having random muscle spasms, but like a great example of this is doing lower body training, where if you have to walk up or specifically more down a flight of stairs, you have that like, ooh, like you feel your legs feel a little rubbery. They feel a little woozy. It's like, okay, like you did some legit damage to those muscles. And so you need to give yourself some time to recover, along with obviously the soreness that can show up in the next couple of days. Whereas if you leave the gym right as rain, you feel fine. And the next day you feel nothing. It's like you probably didn't apply enough stress to the muscle. And then if you crawl out of the gym and then effectively lay like a corpse for 72 hours, like you probably did way too much stress on your tissues for that one day that you're not going to be able to recover at a fast enough rate so you can actually train it again in hopefully less than a full week. But now we're getting to a little bit more of the nuance of training.
So like, to put into perspective from like my point of view, like what you were talking about. So I played softball my whole life.
Mhm.
And I haven't played in well over a year, and I played in a co-ed team the other day, and my shoulder was so sore from throwing, and then like even my quads were hurting from like the way I was sprinting from the bases. And I guess like I wasn't expecting that the next day when I woke up. So like would that be like along the terms of like what we were talking about, like how my body like wasn't used to that from like, yes, I go to the gym, but like those specific muscles that I used playing softball my whole life weren't used to again.
So a couple things. One is get the volume of it, because you go to the gym, but how often you practice throwing a ball in the gym?
Never.
Yeah, exactly. So those muscles are deconditioned, kind of getting back to why my calves were sore from the stair climb and the rest of me wasn't. It turns out it's not just like you have global I am ready and global I am not. It's always specific to what you're doing. And then it's also not just specific to what you're, specific to also the movement pattern. Sprinting is definitely different than squatting, which is different than doing freaking leg extensions. Not that each of those methods or each of those exercise choices are inherently bad or one's better than another. It's the key is that full muscle action and the way that we're receiving the stress and distributing it throughout different tissues in the body. All of those are going to be different. So it's anytime you do something novel, so something the body's not used to, you typically are going to have some soreness. That's why a lot of people grow to love CrossFit, because there's just enough randomness that they can still have that kind of masochistic, like, oh man, I got so sore from whatever I did yesterday. Like, yeah, if I did a random workout every single time I came in, I get sore from it because your body isn't used to that immediate stressor. The problem is the longer that we spend time developing specific motor patterns when it comes to muscle fiber hypertrophy, the better of a job you're going to be doing of activating that muscle and getting the entire muscle to hypertrophy, not because you've stressed a couple of fibers in ways they're not used to. So you kind of get some novelty soreness in different areas, but actually like the really brutal, deep soreness throughout the entire tissue.
Okay.
So.
Makes sense.
Yeah. Too bad Jake's not here for me to kind of talk smack on what he does for a living. I mean, CrossFit is, fine if that's what you're into. The key is it's a tool. And the problem is it's a tool that's really a bunch of other tools that were already around. They just repackaged it and now it's called CrossFit. Like when I was younger, it was simply called being in shape.
Yeah.
And CrossFit tried to patent it. And we're like, no, dog, that's been around for a while. It's called wrestlers. People that did crazy complexes of stuff and just got tired. It just turns out now you're having women do it and you throw in Olympic lifting. Like it's not really that novel, but they've built kind of a following around it where, a lot of folks are into it, and that's fine. That's fine. But if we're really trying to make an athlete as great as we can be, we need those more concentrated stressors. So, but yeah. So does that kind of clarify the soreness? And yeah, as far as the hypertrophy is a long game, like really trying to gain a lean mass. That's the type of work that typically is going to take, we're talking months and or years of concerted effort to really get a significant amount of hypertrophy.
Yes.
The longer you've been doing it, which really sucks.
It does make a lot more sense. It's just, I do better like whenever things are like reiterate it and like put into like examples. I think that's like when I learn the most. It's like in applying things to myself. I don't know. I hear things better that way.
Absolutely. No, I think that's the big key with obviously exercise science, but obviously the things that I teach, which is we can apply all this to ourselves, or you can find examples of it, of seeing different people react to it. Like the gender example for muscle mass differences. My little sister and I, go figure, both, she's only 5'3", and she's 3 years younger than me, which obviously used to mean a lot more before we got into the deep part of our 30s. But at the same time, like one of the main reasons why I have more muscle mass than her is just straight up, I'm male and she's female. Like that's it's literally the testosterone advantage. We both, and I've trained longer than she has and trained harder than she has. But if I had a twin brother and he never worked out, that's where you'd see the difference. That's where you'd be like, okay, that's what happens whenever you do put all those stressors on your body. And that's what you get if you just happen to be male with his genetics. And so, it's the other thing you can look at with people is, getting back to that muscular development is not everybody has balanced development. That's the thing is, it turns out the trap thing, that happened from just doing heavy deadlifting and Olympic lifting for years, which are patterns that require trap movement. And just so happened that I neurologically adapt very well to it and build muscle mass there. Whereas other folks, you'll see the bros of the rec that have no traps because all they do is like a couple, like, I'm trying to shrug this dirt off my shoulders nonsense, and they never pick up anything heavy. So their tissues never really have to adapt and do something. But tell you what, the traps, unfortunately, also the back hair didn't show up until like a deadlift 600 pounds. That being said, I'm not, I don't think the back hair had anything to do with it. I think it just happened to be getting older, but it's still one of those things where you have to that's why I joke, you have to give your tissues an ultimatum. You have to effectively, through stressful training, give your body two options: get better or die. And so then your body's going to do something about it, hopefully, because the second option.
Yeah. No, speaking of the rec, I have little arms compared to most people.
Yeah.
And it's mostly because I don't like working arms, but I'm trying to get better at doing them. Well, like the day I was doing them at the gym, I was getting stared at by a male who had a lot bigger traps, bigger arms, but he had little noodle legs. And I'm like, would you like to switch roles? I will gladly do legs. But
Well,
it's just the way people judge you for it in the gym.
Well, there's a concept from ecology known as a lek, L-E-C. A lek is a piece of land that has no purpose other than for two males to preen and posture to try to get the attention of females. So think of bars and you think of a gym. It's places that bros can peacock and try to, be whatever and walk around. First and foremost, I'd say when you're in there, focus on you. Don't worry about other people. I see enough freestyle weightlifting that I want to say something. And sometimes I do, just because ethically I can't do nothing, but it can be a bit rough. And the other thing when it comes to the arm training, ask yourself, A, do I care? And B, try to find movements that orthopedically and specifically like muscularly, like feel good. Like you actually feel the muscles doing their job, your joints feel good. And hopefully it's something that you can easily increase the load. So, if you enjoy doing the exercise and it feels good orthopedically and you can feel it in that muscle of interest, let it run. For folks like you that have shorter arms, bench press is obviously going to be your friend because you don't have to push it as far. But at the same time, you might not feel like you get much out of it just because you just feel like you're just like and you're done. Using dumbbells allows you to go obviously a bit further range of motion. And once again, due to your stature, most machines in the gym are built for people that are somewhere between, exactly, like 5'5" to like maybe 6 foot. So if you're on either end of the spectrum, you can feel like you're the little kid in the high chair, or you can feel like you're the adult who's having to sit down in a kindergartner's chair. So find what works for you. They also didn't buy very good equipment. Those leg presses are just bad.
I had to use 2 mats like folded up to be able to reach the leg press.
Yep. I've had that problem with some of the other female students I've helped, especially, no offense, the ones that are around the 5 foot mark, where if that's where they should have AirX pads and some other stuff there that you can use that for back support. So you can actually be in a better orthopedic position to start from, but that requires understanding how machines work.
Especially for the people that are just going to the gym without any prior training. They wouldn't know that if they lock their knees, they could seriously injure themselves.
It's unlikely you're going to have enough weight on there that you're going to blow out a knee from hyperextending it. But you're right. At the same time, there's some easy oversight. I don't mean to punch down. That's not fair. It's just, that's why I said I try to help out people when I see them doing stuff, because you get some unique setups because folks are, everybody's in there because they want to get something, they want to improve something. And so, since they're in there and they're willing to, be vulnerable and, all the other bullshit alpha male hierarchy stuff, like it turns out, I've won. I'm old, so I don't care. And B, I'm stronger than pretty much all the damn undergrads anyway, so I don't care. But, I definitely wasn't always. And, you're trying to be friendly. And Lord knows some of those guys are training the upper body because they think that's what women like. And I'm going to leave that one alone. I think you already know the answer there. And you know what? If they're hopefully you're doing it for you,
Yeah.
the shape, because you like having that physical interaction. I just, like hiking and knowing that if something goes wrong, I can grab onto a tree and pull myself up it. There's a plus, I guess I like picking up very heavy things, but, as long as your physical practice is adding to your life, do it to it.
Gotcha.
So anything else you want to review?
The only other question, so I've went through the slideshow. What is like one specific thing that should be highlighted in this chapter that like I should know? Like I know I need to know all of it, but like a specific, like the most important part.
So think of it like a flow chart. I would say the first spot of the flow chart is understanding that, what are the three parts of our cardiovascular system. So it's not pulmonary yet, which we're going to get into next, and that's when we're talking about lungs. So we've got the heart itself, our vasculature, and the blood. So then we have to know, okay, why is the heart important? But understanding, okay, how's the heart work electrically? How's it work as far as pumping the blood through? And why do we care about things specifically, how the left ventricle is going to change with training? So we're talking about those improvements in stroke volume. Okay. Blood vessels, okay, how are we changing our ability to send blood to certain areas and remove it from others? So vasodilation, vasoconstriction. Do we understand also, kind of how those are going to change with training as well? And we're going to build new capillaries, and that's going to be through interception and branching, which we'll talk a little bit about actually in person when I see you guys. Remind me on that if I forget. And then obviously how, what makes up our blood, and then how our blood's also going to change with training. So we're going to increase the fluid amount, and then we're going to increase our hematocrit through more red blood cells. So once you kind of got the basics there, takes from there, it is really creepy to see little pictures of myself. And I realized, oh yeah, that's the cat. That's Tinks making her appearance because she is super friendly, which is dumb. The good news is my wife and brother-in-law are over in the other room, so the cats are hanging out with them, and the gingers are sleeping on the floor where he was. So I'd say that's kind of the big parts. Yeah, understanding how how cardiac fiber. You can see how it's hard because everything kind of goes together. Obviously, if we understand the sympathetic and parasympathetic on heart production or heart performance, so the heart rate and then how it electrically is going to break down. Yeah, and then boom, Wigger's diagram. Understanding this guy is a big thing, because if you understand Wigger's diagram, then you understand the cardiac cycle.
Could you go over that with me?
Yeah, no worries. Okay, so effectively, as we're reading from left to right, that's time. Now, as we're going through each of the lines, we're going through different units, so that can throw people off. The first three lines, notice that's pressure, so that's millimeters mercury, aka when you think about blood pressure. From there, we have what is going to be the volume, so that's the green line, how much blood is actually in the ventricle. And then the yellow line, that is the electrical conductivity. And that, is going to be in millivolts, but they didn't bother stacking the units there for it. And then finally, we have the phonograph, aka the sound. So it's going to be the sounds of valves opening and closing. So as we're reading from left to right, we can see how the first thing we're going to have, if you kind of start from the first thing you see move, and that's going to be the P wave. So now our atria contracting. So that's how you see a little peak in both atrial pressure, and you see the ventricular volume go up. Now, once we hit that QRS complex, now the ventricle's contracting. So there's no more blood going into the left ventricle or the right ventricle. So the mitral valve, tricuspid valves, or bicuspid valves, they're going to all be shut. And so there's what's known as an isovolumic contraction. So you can see that line right there, where literally the ventricles are contracting, but the aortic valve is shut, and so is the mitral valve is shut. So like nothing is leaving the heart. It's just building pressure in that fluid until it overcomes that aortic pressure. So that's when the aortic valve opens, and boom, we have ejection, because now notice ventricular pressure is higher than aortic pressure. So that's why you see your volume go way down. Now at the same time, we've got our T waves. So now our ventricles are repolarizing, so they're relaxing. So eventually the pressure is going to come down. And that's when we're going to see no blood is going to be leaving the ventricle anymore, but also it's not refilling until we, boom, come down to atrial pressure. And then we start filling again.
Okay.
So, and you can see as well, we had that valve closure. Now, this is, like I said, it's complicated, but I mean, if you understand how this occurs, then you've got a good footing for, okay, Why do we care about people that have got atrial flutter? Well, it turns out you're losing this little extra atrial kick at the end. So think of it, you're not going to fill that extra, we'll say another 10, 20 milliliters of blood into the heart. Instead, we're going to be missing that. So instead, we're only going to go from 90 down to 50. So we're only getting 40 mils of blood out per beat. That's not good. Turns out your cardiac performance is going to really suck. Same thing as if we're just, you can see how folks are in better shape, they're going to have a bigger stroke volume. So that'll be moved vertically. Notice the initial pressure we overcome where blood leaves the heart. That is our diastolic blood pressure. That's the minimum pressure we're going to see in those aorta to move things around. And then the top part here, that is our systolic blood pressure. That is literally when the heart is pumping as hard as it can to get blood out of the heart. And so how that's going to change when we're exercising, our heart's going to beat harder. So the first initial pressure probably won't change much at all, or it might go down, might go up a little bit, but this peak pressure is going to go way up, especially depending on what we're doing and the effort we're giving, because the heart is literally pumping with greater force.
So like when you're like breathing really heavy and your heart's racing, would those all be closer together, like happening like at a lot closer?
Bingo.
times?
Because remember, this is over time. So exactly.
Okay.
And this distance from one beat to the next, when you're chilling out like you are right now, can easily be 1 second. When you're going 100%, it can be less than a third of a second from one heartbeat to the next.
Would it be like the same as me like sitting here and then like sleeping, or would it be even slower while we're sleeping?
It's probably gonna be slower when you're sleeping, because remember, you're laying down, which gives you the lowest metabolic demands. Part of the reason your metabolic demands are higher right now, specifically for me, is I'm standing. So my heart has to pump that blood vertically all the way up to my brain. So it requires more effort. When I'm laying down, the furthest distance between the top and the bottom is relatively small. But when we're like this, it's a lot more work.
And is that why like when you're like unconscious, your like reflexes and such are a lot faster, because like that signal doesn't go to your brain? Like
Well,
it
your
doesn't have
reflexes
to.
are faster in general. I know you
Mhm.
brought it up in your take home, and that's a good point.
Yes.
Reflexes are essentially just workarounds. So we just go through the spinal column and then right back, as opposed to when you have to go all the way up, think about it, and then send in the signal. So, my brother-in-law's here, I don't mind abusing him. So what I'm going to go do is, put like some Legos on the floor when he's not paying attention. As soon as he steps on one, he's going to be like, oh, he's going to pull his foot up quickly because it's going to be like, ouch. But the actual signal to his brain of like, I just stepped on a Lego and my brother-in-law is a jerk, isn't going to come to his mind until he's already lifted his foot off the ground.
Yeah. Okay.
Yeah. So our reflexes, whether we're conscious or unconscious, are always faster than conscious thought, just because it takes another thing. So yeah, that was one of the things that got some of the folks in the take-home assignment, is when they're thinking about how quickly a signal can go, the signal's got to go from wherever we received it all the way into the brain to be processed. And then that signal goes out to the muscles so we can resolve it. So we can myelinate that and increase the diameter. We're going to be able to send that signal faster. So that's going to help, but we're still going to be limited on how quickly that information can go.
I gotcha.
Yeah.
So
like,
again, with like the diagram that we had just went over. So a better way, I feel like, for me to learn it, I guess I'm asking you if it'd be better if I like applied it to like, say I was like working out, like I think like that's when it's going to be higher. It's going to be like closer together. Like, would that be like an easy way for me to like remember how like this is going to like work? Like applying it to a situation.
No, that's the entire point. The goal is to not prepare you to go on a game show. The goal is to have it so you can apply the knowledge.
Okay. Because that's like seeing like the big like humps in it. That's like was my first thought. I'm like, it's gonna be closer together when your heart's beating faster, which is gonna mean everything's gonna be like pushed together.
Yeah, exactly. And then remember, think about how that stroke volume changes. So you're probably going to see an even higher filling. So this green line would move up, and we might even get a little bit better ejection fraction. So this bottom line is going to go down a little bit.
Okay.
Yeah. Like I said, think it through. There's a lot going on there. So
there definitely is.
Yeah, it turns out the body's relatively complicated. So yeah,
I think that's one thing I really love about my major is how your body does all these different things, like learning about how everyone's bodies is different. Everyone applies things differently. I think that's why I love it. Everything's different. I don't like uniform. Like I cannot sit in an office setting and do the same things.
we're always solving problems. You're right. How similar one problem is to the next is always going to, it's gonna be part of what makes people interested or not interested in doing different jobs. And, the key is to, try to dig a little deeper. So, any other questions? Feel good?
I feel pretty good about all this.
Awesome.
Looking forward to starting back to class in person again. So
Amen.
hoping
Yeah.
everything's going well at home.
Yeah, we're doing pretty good. So
Definitely, you guys have been in my thoughts and prayers all week. Like hoping everything's gone well.
Oh yeah, it's been pretty good. I'll hopefully have some kind of jokes whenever I see you guys in person, because so far it definitely hasn't been as much of a nightmare ride as other parts of the endeavor. Is that about? Would you say that's fair, hon? It's definitely not fun. Yeah, this is not a ride I'd like to ride again, but
No,
it's not as
T-Rex arms.
yeah. Well, yeah, she can feed herself and
Good.
now play with her phone a little bit. So she's no longer need an oxy every 4 hours. She's slowly starting to feel a bit more like a human. But anyway, so appreciate it. You have a great day, Madeline, and I'm going to go and shut this down. So we'll see you in class on Friday. So
what about tomorrow? I'll see you tomorrow.